we're continuing with section 15.1 and we're doing some Riemann sum examples. Example 1, approximate the double integral over the region 1 and 9 times 0 and 3 of the function xy dA. dA is the infinitesimal area element as a Riemann sum S 4 and 3. That means that you're dividing the x direction into 4 and y direction into 3 using the midpoints of each rectangle as a sample point. Then repeat with the upper left point. So the first thing that I would do is I draw the domain. Domain is going to be in xy plane, right? So that's the easier part to draw. It says 1 and 9, 1 over here, 9 over here, and times 0 and 3. And let's say 3 over here. So basically, if you draw, and I'm putting the, and 0 I didn't have to draw because the x-axis was there. So you have this rectangle, it's the region R. And now it's asking you to divide the x-axis into 4 pieces and y-axis into 3 pieces. So delta x is going to be 9 minus 1 divided by 4, which is 2. Delta y is going to be 3 minus 0 divided by 3, which is 1. So this one is 3, this one is 5, this one is 7, 1 and 2, and here is how the domain is supposed to be be divided into little rectangles. And now what is the next thing that it's asking? It's saying first do sample point that are the midpoint. What are the midpoint? Midpoints are right in the middle, and so that's for each rectangle, it's the average of the x values and average of the y values. So for example, that one is 2 and 0.5. So you have 2 and 0.5. Then over here is 4 and 0.5. Then over here is 6 and 0.5. Then over there is 8 and 0.5. Then go up here, you have the sample point is this time 2 and 1.5. Again, averaging x's and y values. And now you see a pattern. So you can continue just writing it down without averaging it out every time. And then the last piece would be 2 and 2.5, 4 and 2.5, 6 and 2.5, and 8 and 2.5. Right, so I went first row is this one, second row is this one, and the third row is that one. Maybe I should have written it as a row also, but written them as rows rather than columns, but you can kind of look at it the other way around and you get that. So now, what is delta x times delta y? Delta x times delta y for every rectangle is 2. What you need to do is for each of these rectangles, find the z value. How do I find the z value? By plugging into the function. So the z value for the first one is going to be 1, for this one is 2, for that one is 6 times 0.5 is 3, 8 times 0.5 is 4. Z value for these are 2 times 1.5, 3, 4 times 1.5, 6 times 1.5 is going to be 9, and then 8 times 1.5 is going to be 12. And again, those values. So I prod this function is x times y, so you can find them all. Now what do? It's basically the function times 2, the value of the function times 2, value of the function times 2, and all of that. You can factor the 2 out and add up all the values of the functions to find the midpoint approximation. So basically that's how it looks like, and then you know the dA is that, and then those are the values of the functions, and you find the sum 4 and 3 with the midpoints. Now what do I do when it's this was the first part, then was another part, right? So this is the answer to midpoint. This one is the answer to midpoint. Of course you compute this completely, and it becomes 180. Now how do I find the upper left point? This time again the same rectangle, and upper left for that, this rectangle is right there, there, and then for that one there, for that one there, and that one. And so you end up with, let's see, and I covered all these. So you end up with these points, and you have to figure them out. Like over here, if I this time follow the rows, I get 1 and 1, then I get 2 and 1, and then 3 and 1, and so on. And then second row it would be 1 and 2, and 2 and 2, and so on. The last row is going to be 1 and 3, and 2 and 3, and so on. And so you find the y value for each of these points, and you multiply. By the way, delta A did not change because it's still delta x times delta y, which is 2. And so you multiply it by delta A. And this is how you find the area, the estimation with the upper left point, basically, which is going to turn out to be 192.